So when you're practicing medicine, if you're paying any attention at all, you're always conscious of the fact that you're making mistakes.
There's a big gap between what we can do technologically and what actually gets delivered in healthcare currently.
We think there's a ton of potential in imaging data to really unlock new medical knowledge, but that has not been able to happen because the data is just not available.
If you think about one single image in pathology, those are gigapixel kind of images. I would say they're one of the largest data sets in the healthcare system is embedded into those pathology images. The opportunities in terms of information there are probably gigantic, they're untapped.
All around the country, we're gathering all of these data. We're doing x-rays, we're doing MRIs and CTs, we're doing slides, and we're just letting them sit in basements where they're gathering dust, and nobody's using them to start pushing that science forward.
So what we're really doing at Nightingale is working hand in hand with health systems all over the world to build up imaging data sets to really unlock new medical knowledge. We have a great partnership with Providence St. Joseph, and we have collaborated with them on a few different projects.
So Providence is one of the largest healthcare systems in the country. I think we have more than 45,000 new cancer cases a year. So you can imagine there's an incredible breadth of data. And we had the fortune of being approached by Nightingale with a focus of actually leveraging the machine learning on large data sets.
A lot of the tools that we have available to us right now and that people are building are looking at an image and training an algorithm to say, is there a tumor there or not, based on things that human doctors already look for. What we're doing is very different. We're tying those images to real outcomes from patients, sometimes years in advance, like, is there a metastasis 3 years later? Does that patient die? How do they respond to chemotherapy? And so algorithms and artificial intelligence in general looks at very complex data that are too complex for humans to process in a lot of cases, about what your x-ray or your biopsy specimen looks like, and they turn those very complicated data into a simple prediction on an outcome. For example, are you the kind of person who's going to have metastasis in a few years from a cancer that looks like this? And so having very high precision, high resolution imagery, I think is really, really important, because even if a human can't tell the difference between the normal version and the very high resolution version, it's quite likely that an algorithm can and can find signal in that added resolution that can be really important for predicting important patient outcomes. And that's one of the reasons that I'm so excited to be collaborating with Providence St. Joseph and also with Hamamatsu, because I think that that high resolution, very precise imagery is going to be really, really important for unlocking the potential of the data going forward.
Hamamatsu is all about light. Our study and understanding of light allow our products to use the basic nature of light to improve our lives. And that's why we are so excited about this collaboration with Nightingale Open Science. We're excited these scanners are the foundation of our partnership with Nightingale and provide the images that will enable physicians and scientists to make breakthroughs in healthcare.
We truly believe that the NanoZooma S360 is a game changer for digital pathology. And we are excited. Hamamatsu Photonics got the FDA clearance for the NanoZooma S360 MD slide scanner system. At Hamamatsu Photonics, everything that we built is constructed with a mind towards precision and longevity. And we are excited to see how our scanner will be used to better serve pathology labs and patients.
We are so grateful for the partnership of Hamamatsu in really empowering and enabling our flagship partnership with Providence, which is to bring these breast cancer biopsy slides online in a digital format and link them up with other valuable data. So my hope is that we uncover new knowledge faster and can get the results out into the world.
It's going to come to fruition. We're just trying to make it happen quicker.
We have cures for a lot of things like heart disease and cancer if we catch them early enough. And so I think machine learning, by catching those problems early, by letting us understand who's at high risk, who needs help today, is going to let us target those treatments to the right patient at the right time and really provide a lot of opportunities to make people's lives longer and better.